अस्सलाम वालेकुम। आज की जो हमारी वीडियो है वो ऑर्गेनिक केमिस्ट्री के एक अहम टॉपिक पे और जिसका टॉपिक का नेम है और एरोमेटिसिटी एंड फर्स्ट ऑफ ऑल वी डिस्कस एरोमेटिक कंपाउंड्स. Aromatic compounds are those which resemble to benzene in their chemical behavior. Means that these compounds are almost derivatives of the benzene, and they have always cyclic structure. So therefore, we consider that they are similar to benzene in their chemical behavior. For example, we have a few examples of pyrrole, pyrimidine, thiophene, and furan. You can see all these structures are in circular form, so therefore they are considered as aromatic compounds. Now, why we call these compounds are aromatic, and why some compounds we say that they are not aromatic? So, what is the difference? We can't say that all the circular ring structures are aromatic. No, sometimes we have many rings which are considered as non-aromatic and anti-aromatic. So, why we call them non-aromatic and anti-aromatic? We discuss in this video. So, keep watching. First of all, we define aromaticity, that the property of conjugated cycloalkenes in which molecules stabilize by delocalization of pi electrons. Mean that if we have if we have conjugation in cycloalkenes, for example, we have in cyclic form of alkenes, and these cyclic form of alkenes, if show conjugation in them, means that they show double conjugation, mean they show pi sigma pi, and they could show pi sigma positive charge, they can show pi sigma lone pair. So if they show this like uh, a formation, then we call them that they are conjugated. For example, in furan we have double bond pi sigma pi lone pair. We in thiophene we have double bond pi sigma pi lone pair. So in this way we can say that they are conjugated. And if we have a cycloalkene and which can show conjugation in them, then it should have pi electrons, and this thick localization of pi electron make this molecule more stable. So this is the definition of aromaticity, and it is a phenomena which is only shown by aromatic compounds. Now we have to decide Huckel's rule. Huckel's rule decide whether a compound is aromatic or not. Now first of all, we discuss the discovery of Huckel rule. In 1931, German chemist Ernest Haeckel proposed a theory on aromaticity and the aromatic compounds. First of all, we define that what is Haeckel rule. If a cyclic and a planar molecule mean this molecule should have two-dimensional structure and has 4n plus 2 pi electrons in it, then it considered as aromatic compound. Now, Haeckel rule is a combination of pi electron and the physical structure of the ring to determine whether a structure is aromatic or non-aromatic. Okay, now we have a formula to decide that this compound is aromatic or non-aromatic. First of all, we have a formula for aromatic compounds. This formula is n is equal to 4n plus 2, where n is an integer and the value of n is from n is equal to 0, 1, 2, 3, and up to so on. Now the formula for the anti-aromatic compound is n is equal to 4n, and where n is an integer and the value of n is 1, 2, 3, and up to so on. So in an anti-aromatic compound, the formula and the value of n is different. That in this formula, the value of n is not equal to 0, it greater than 0. Now we move further. We have a set criteria of aromatic compound. We set criteria for the non aromatic, and we have set a criteria for the anti aromatic compounds. Now if a compound follow the criteria of aromatic compound, then it should be aromatic. if a compound follow all the criteria, all the steps of non aromatic compound, then it is non aromatic molecule. First of all, um aromatic compound should have cyclic structure, mean a ring of atom, and the molecule should be planar, means all the atoms are in the same plane in two dimensional structure, and all the carbon must have sp2 hybridization in them. This is very important point. And all the molecules should be fully conjugated, means that they should show pi sigma lone pair, and pi sigma positive charge. Conjugation mean resonance, and molecule should obey 4n plus 2 pi electrons rule, which is Huckel rule. So the value of n is 0, 1, 2, 3, and up to so on. Now the criteria for the non-aromatic compound, that molecule should be cyclic, but molecule has no conjugation in it, then any molecule has no resonance in it. Now the criteria for the anti-aromatic is that molecule should be cyclic, molecule should be conjugated, and should have planar, but the formula is different, so therefore the number of pi electrons are different. So the main difference between the criteria of aromatic and the anti-aromatic compound is that in aromatic compounds we have different number of pi electrons, mean aromatic compounds have two electron more than the non-aromatic compound. So this is the major difference between the aromatic and the non-aromatic compound. Now we have some examples. First of all, these structures are given to you, and then they ask that how could you identify that this molecule is aromatic or this is non-aromatic. How would you tackle it? By using Hucker rule. First of all, we apply Hucker rule on the structure number 1. We see that it has 1, 2, 3, 4, 5. 5 carbon member ring is present in front of us. First of all, we have to see that this structure must be cyclic. So we see that it has a cyclic structure, so we mention C. Then you add comma, and then C, and C means non conjugation. Mean this molecule cannot show conjugation. For example, we have pi, sigma, then again sigma, and then we have pi and sigma. So sigma sigma cannot be come together with each other, so therefore it has no conjugation in them. And the pi electron is 1, 2, 3, and 4. So we have 4 pi electrons. So the molecule which have no conjugation in them is called as non aromatic compound. Now we have another structure. You see that it is a 6-member ring, and it is in ring form, so therefore it is cyclic form. Non conjugation because it is sigma pi sigma sigma pi sigma, so therefore sigma come together with each other, so therefore it is non conjugated. And it also have 4 pi electrons, so therefore it is non aromatic. So where there is non conjugation, there will be non aromatic compound. Now we have another structure. You see that it is cyclic, so we write C. Then we see that it is conjugated or not. So see, it is sigma pi sigma lone pair sigma pi sigma. So we see that it is conjugated. So then we count its pi electrons. The number of pi electrons are 1, 2, 3, 4, 5, 6. So it has 6 pi electrons. So we see that in the formula 4n plus 2, because we see it has 6 electrons, so therefore we put n is equal to 1. When we put n is equal to 1, then we get the answer 6. So it means the compound having 6 pi electron is aromatic. So therefore it has 6 electron, it show conjugation, it is cyclic, so we call that it is aromatic compound. Now we have another structure. It has sigma pi sigma sigma positive charge, sigma, sigma, and pi. So therefore we see that it is cyclic, but it has no conjugation in it, and it has only two electrons in them. The compound with two electron is aromatic, but due to presence of non-conjugation molecule, it is non-aromatic compound. So we have another structure. In this structure we have cyclic structure, but in this structure we have no conjugation. For example, pi, sigma, sigma, lone pair, sigma, sigma, and pi. So therefore we have no conjugation in it, and the number of pi electrons in it is 1, 2, and 3, 4. So therefore, due to non conjugation in this molecule, we consider this molecule as non aromatic. Now we have this structure. In this structure we see that it is cyclic, and for the conjugation we have pi, sigma, pi, sigma, lone pair. So we see that this molecule have conjugation in it. Now we count pi electron present in them. First we have 1, 2, 3, 4, and 5, 6. Now these pack of lone pair is present outside the sulfur, so therefore we can't count these electrons. We count the lone pair which is present inside the ring. So therefore it has only 6 pi electron in it, and I have explained to you that a molecule with 6 pi electron is considered as aromatic compound. So therefore it is aromatic. Now we have another structure. In this structure we have a lone pair on the nitrogen atom outside the ring, so therefore we can't count this lone pair in pi electrons. So therefore it is conjugated, but the number of pi electron is only 6, so therefore it is aromatic. Now we have this structure. In this structure this is cyclic, and it is conjugated because it have pi, sigma, positive charge, sigma, pi. So therefore it is conjugated, and it has only two electrons. So I say if we have n is equal to 0, then we put in the formula and we get 2. So therefore it is proved that a molecule with 2 pi electron is considered as aromatic compound. Now we have another structure. In this structure you see that it is cyclic and it is conjugated because it has distribution pi, sigma, lone pair, sigma, pi, and it has 4 pi electrons, 1, 2, and 3, 4. So therefore a compound with conjugated and 4 electron is considered as anti-aromatic. For example, for anti-aromatic compounds we have a formula 4n. So in this compound we have n is equal to 1, so therefore our answer will be 4. So a molecule with 4 pi electron is considered as anti-aromatic compound. So this compound is considered as anti-aromatic. Now we have another example of anti-aromatic compound. In this compound we see that it is cyclic and it have conjugation in it. For example, sigma pi, and it has 4 electrons in it. So therefore a molecule with 4 pi electron is considered as anti-aromatic compound. Now in this structure we see that we have two positive charges. So pi, sigma, positive charge, sigma, positive charge, sigma, pi. So therefore it has conjugation in it, and it has only two electrons in it, so it is aromatic compound. Now in this structure we have only one positive charge, uh, pi, sigma, positive charge, sigma, sigma, and positive charge. So therefore it has no conjugation in it and have only two electrons in it. So therefore due to non conjugation it is non aromatic compound. Now in this structure it is cyclic and the conjugation is not, because two sigma bonds are in front of each other. So therefore it has only two pi electrons. So therefore due to non conjugation it is non aromatic compound. And this is the structure of furan, and furan is aromatic compound. Now in this structure, if you see that the structure, you see that it is pi bond and it is sigma and it is sigma, so it has no conjugation and it is non-aromatic. This is wrong concept, because we have a double bonded oxygen attached to it, so we can't consider these two bonds as the sigma bond. We have to transfer one double bond of the oxygen to on the oxygen atom as a negative charge, and the positive charge formation occurs there. Then we count this as pi sigma positive charge sigma pi. So in this way conjugation occur, and two lone pair pi electrons are present, so therefore it considered as aromatic compound. This is the correct way to explain that whether a compound is aromatic or not. Now we have another critical example. In this molecule we have two oxygen atom, one is double bonded and one is attached inside the ring. We cannot count these lone pair into the pi electrons, so therefore we have pi. First of all, we have to transfer this bond on the oxygen atom as a negative charge and positive charge form here. Now we count for the conjugation: pi sigma pi sigma positive charge sigma lone pair sigma pi. So therefore it has conjugation, and it has 1 2 3 4 and 5 6. So it has 6 pi electrons, so therefore a compound with 6 pi electron is considered as aromatic, so it is aromatic. Now we have this example. In this example we have cyclic, and it has no conjugation because two sigma bonds are in front of each other, and it has only four pi electrons, so therefore due to four electrons it is considered as anti-aromatic compound. No, oh sorry, it has no conjugation, so therefore it is non aromatic compound, not anti-aromatic compound. Now we have this example. In this example, positive charge and lone pair is present on the oxygen atom. As we can see that the oxygen has two lone pairs. Okay. Now if we say that oxygen donates its one lone pair to another oxygen atom, then what come? Lone pair. This lone pair remains same, while due to the donation of this lone pair we have a positive charge here, so this is present at that side. Okay. Now we count that sigma pi sigma pi sigma pi positive charge, so it has conjugation, and the number of pi electrons are 1 2 3 4 and 5 6. We can't count these lone pair, these are outside the ring. We can only count only those pi electrons which are present inside the ring, so it is present outside the ring, so therefore we can't count it, so it is considered as aromatic compound. Now we have some more examples. जी, this compound is non-aromatic because it has no conjugation in it. Due to no conjugation, it is non-aromatic. Now in this compound, this is not cyclic compound and this has no conjugation, so therefore it is non-aromatic. And it is also non-aromatic. It is methane, so it has no circular ring form, so therefore it is non-aromatic. Then we have this like structure, and this is anti-aromatic because it has 8 pi electrons and zero conjugation. Now we have naphthalene structure. In naphthalene you have to count like this. First of all, pi sigma pi, oh sorry, pi sigma pi sigma pi sigma pi sigma pi. So in this way you count, and you have 10 pi electrons, so 10 pi electrons, for 10 pi electrons we have n is equal to 2, so 4 into 2 plus 2, then we have 10. So in this way 10 pi electrons is also considered as aromatic compound. Now we have anthracene. This is the structure of anthracene. So in anthracene we have pi sigma pi sigma pi sigma pi sigma pi sigma pi sigma pi sigma. So in this way we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14 pi electrons. So a compound with 14 would be n is equal to, okay, then for this we have n is equal to 3, so we put in it and then we got 14. So in this way we consider that 14 is a aromatic compound. Now we have this molecule, and in this molecule we have nitrogen negative charge because nitrogen gain a lone pair from it. We see that nitrogen has only one lone pair on it. If it receive a lone pair from another electronegative compound, then it came negative charge on it. Okay, this is represented here that it has negative charge and it has extra lone pair. So we count that it has cyclic and it is conjugated and 6 pi electrons, so therefore it is aromatic. Now we count this and it occur anti-aromatic. Now we have stability order. First of all, the most stable compounds are the aromatic, then we have non-aromatic, and then anti-aromatic. Anti-aromatic are least stable, so therefore they convert themselves into non-aromatic and the aromatic compounds. Now how they transfer themselves, for example, it is anti-aromatic compound. It's combined with its similar structure and form this like structure, and it is become non-aromatic. For example, it has this lone pair, uh, this lone pair transfer to there, and this lone pair transfer to that way. Okay, due to this transfer, this pi electron came at that side. Okay, and this pi electron came on that side. So therefore we have 1 2 3 4 5 6 7 8 8 pi electrons. So therefore 8 pi electron, it is non-aromatic. So we see that how anti-aromatic compound change into non-aromatic compound, which is more stable than the anti-aromatic compound. Now we see how a anti-aromatic compound change into a directly aromatic compound. We have to react this anti-aromatic compound with a metal. Now we, in this way we have a metal sodium, and we react this metal with the anti-aromatic compound in presence of ether, and we got this structure, and it has 6 pi electrons, 1 2 3 4 and 5 6. So 6 pi electron considered as aromatic. Now if we have this and this structure, and we react this structure with silver ion, so silver ion combined with bromide ion to form AgBr, and the positive charge came here, and this structure is more stable because it is aromatic and 6 pi electron, and it has 4 pi electrons, so therefore it is non-aromatic. Oh sorry, it would be anti-aromatic. Oh g, it is anti-aromatic, so therefore it is less stable and it is more stable than its this structure. So this is for the today's lecture. I hope that you will like it. Please like, share and subscribe this video, and Allah Hafiz, stay tuned.